I want to talk about a general relativity test in the year 2017 and 2024 for the upcoming total solar eclipse across the United States. Einstein, back in December 1915, he published his field equations for general relativity. This is now May 2015, so this is the 100th anniversary of the year of his publication. And one of the things that came out of the general relativity that Einstein predicted was that starlight passing close to the sun will have its path deflected by the gravitational field of the sun. And that's what I'm trying to show here, but this is not the scale. This is greatly, greatly exaggerated. So here's the sun, here's a star, and here we are down here on Earth. The starlight, which would normally go along this path, is passing close to the limb of the sun and gets bent, gets deflected. So from here on Earth, it looks like to us that the star is over here. So the star's position has shifted from our point of view on Earth. And according to Einstein's general relativity, the angle of that deflection is 4gm over c squared r. G is the gravitational constant, m is the mass of the sun, r is the distance out that the starlight is passing near the sun, and c is the speed of light. And if you put in these parameters and you work it out for the case where the starlight is just grazing the edge of the sun, grazing the limit of the sun, the angle, the largest angle you would get in this deviation, again greatly exaggerated here, is 1.75 arc seconds. 1.75 arc seconds for a ray at the sun's limb. So what that means, here you're on the ground, you're looking up at the sky, and there's the sun. And if you could see the stars, you would see the stars deflected away from their positions. Einstein's idea that he published was tested during a total eclipse of the sun. That's the way to see the stars. The moon covers the sun. It's a total solar eclipse. You can see the stars. You can take a photograph. You can compare the position of the stars near the sun with stars far away. Stars far away are not going to have any deviation in their position. Their position won't change, but the stars close to the sun, they'll move away, as shown here. So anyhow, back in 1919, 29th of May, there was a total eclipse of the sun. The sun's shadow from the moon passing in front of the sun went from South America to Africa, and people measured the displacement of the stars during the total eclipse back then, and they found that it was in pretty good agreement with what Einstein predicted through his theory of general relativity. So now I want to show you where the sun is going to be relative to the stars during the upcoming eclipses. So for the total solar eclipse on the 21st, which is going to occur on the 21st of August in 2017, it's across the United States. This is a map I borrowed from this website. And the path starts out over the Pacific, goes across the path of the total eclipse, goes through Oregon, Idaho, comes down, and goes off the shore of South Carolina, passing through Nebraska and Missouri. So at the time of the eclipse, this spot here represents the position of the sun and the moon. This is sort of a relative scale, but you can see constellation Leo, Virgo, Bootes, Leo Minor, Cancer, Gemini, and Orion. And when this eclipse occurs, the planets Mercury, Jupiter, Mars, and Venus should be visible. But what we're interested in is what stars are going to be in the vicinity of the sun. And what is really remarkable is that the bright star Regulus, the brightest star in the constellation Leo, is going to be pretty close to the sun. Now down here what I did was I magnified that region. So here's Regulus, here's its magnitude, 1.36. I show other stars with their names and their magnitudes. And this is pretty close to correct scale, showing the moon covering the sun, and this is the direction that the moon would be moving in. And I show other stars around. So Regulus is a very good candidate to study during this total solar eclipse in 2017 to check out Einstein's theory of general relativity. There's far better ways to test it, but this is something that almost anyone would be able to do. Then, by chance, we have another total eclipse a few years later on 8th of April in 2024. That path starts out coming across Texas and works its way up over Lake Erie, Lake Ontario, and probably one of the most popular places to be on that date will be Niagara Falls. It'll be an amazing sight to see the sun eclipsed and to look at the falls at the same time. So if you want a room, you better get it now. And this is the star map. Again, this is borrowed from the NASA government site. This star map of mine, it shows where the sun and the moon will be at the time of the total eclipse. It also shows that some planets will be around Jupiter, Mercury, Venus, Mars, and Saturn. In constellation, Pisces, Andromeda, the Triangulum, Aries, and Ceres. And again, just like in the other diagram, I've blown this up. The line connecting these stars is this line here, and the star Epsilon in Pisces is shown here. It's not very bright, 4.3, but there are some stars nearby. I only marked a few of them. They're not very bright, 6.4 magnitude, 5.2, 6.0, and so on. But there are still stars around that at the time of the eclipse, you could photograph this and compare it to what the sky looked like when the sun and the moon weren't there during the total eclipse. So basically, 6 months before the eclipse, you would photograph that part of the sky, and then you photograph the same part of the sky during the eclipse, and you compare the star positions between the two different photographs, and you should be able to detect a shift in the position of the stars as predicted by Einstein's general relativity. So if the weather's good, there's going to be two good opportunities to do this test, if the weather's good. One of the other things to consider is when the sun does pass behind, appears to us to pass behind the moon, we do see the sun's outer corona. And that outer corona, depending on which way it is oriented, might hamper the ability to see stars, especially the fainter ones. It shouldn't be a problem in the case of the bright star Regulus in Leo. But over here, the fainter stars may be a problem. And what I wanted to show over here, I'm showing you the solar cycle. This is a very rough sketch. I'm showing you the solar cycle, smooth sunspot numbers from 1985 all the way up to 2025, with this being a guess in between here. And I'm showing you the approximate locations of the two eclipses, the one in 2017 and 2024. And the corona of the sun varies during the solar cycle. And again, this is very crude, but what I'm trying to show is that at the peaks of the cycle, it's more or less kind of uniform out, whereas in the minimums in the solar cycle, it's more or less spread out along its equator. And so it may very well be that since we're going between a peak and a null in the, or a peak and a low point in the solar cycle for these two eclipses, the extent, especially on April 8th, 2024, the extent of the corona might interfere with detecting some of the fainter stars shown here. But that's a really great opportunity, these two solar eclipses, to give a test of general relativity. It's going to be a lot easier than it was back on the 29th of May 1919 when you consider the type of cameras that are available now, and also the quality telescopes, relatively inexpensive telescopes that you can get. And so running through this general relativity test, drawing these two eclipses across the United States, it would be a good project for high school students to work on.